we're going to talk a little bit more about the domain of a function. During this unit, we're going to be looking a lot at domain and range. And so first, we're going to kind of just talk about domain. So remember, the domain represents the x values of the function, or we could think of those as the inputs. And so if we were looking at just a table of values, 1, 2, 3, 4, 5, I could tell you that the domain was 1, 2, 3, 4, and 5, if we're looking at just like a finite number of things. So let's say this was 5, 4, 3, 2, 1, we would have 5, 4, 3, 2, 1. Whoops, I got off by 1. Let's bring that down. There we go. Whoops, bring it up. Something like that. Okay, so there is the domain if it's just finite, if it's just 5 different things. But, an equation might tell us that the domain is something else entirely. What if our equation told us, what if our equation was something like y equals x squared? In this case, it would take us a very long time to fill out a table of values that represented all of those, because that table of values is going to be infinite, because the domain is something like this. Whoop! The domain would be all real numbers. Sometimes we list that as just like a fancy R. And what we learned last class was that we can list that using interval notation, saying our domain goes from negative infinity to positive infinity using interval notation, that all of the values of x are acceptable. And if we think about that in terms of an equation, no number that we plug in can't be squared. Like, you can square any number that you want. Where we start to get into trouble is when we break math rules. So I want us to think for a moment about, like, what math rules are there? Well, math rules. Okay, so we can't divide by 0. That's a big one. Like, don't ever do that. Another one that we can't do and get a real number, and again, if we're graphing with x and y, we're on the real number plane. Real numbers only. We can't divide by 0. We can't take the square root of a negative number, or can't even root. So we couldn't take a 4th root or a 6th root of a negative number. So let's think about this. Y equals the square root of x. Now, this differs from our last video because there isn't a plus or a minus. It's just the square root of x. So if we think about the square root of x, possible values for the square root of x, the square root of 0 is 0. The square root of 1 is 1. The square root of 2 is like root 2, which is like approximately 1.3 something, 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 right? It's irrational. It goes on forever. And if I skip to 4, we'd say the square root of 4 is 2. So I've got 0, 0. I've got 1, 1. I've got 4, 2. I've got like 1.3 something, 1.7 something. I could even go all the way to 9, 3, maybe like there. There. So, no, I was right the first time. There. So we have that. But I cannot take the square root of negative 1 and get, I shouldn't say x, I should say NA. I can't do it and get a real number. I would be graphing in the imaginary plane, which we did when we talked about quadratics. So we know that the imaginary plane exists, at least in our imagination, but if we define that, like, we're working with real numbers only, then we would say we cannot do this. Like, that's a no-no. And we might even say that, like, we can't do anything over here. Like, nothing in our table, I'll like here, nothing in our graph can exist over there. So when we talk about the domain for this, we would say we can begin at 0, but we can't go backwards, no negative numbers, and we can continue on infinitely. So when we think about values in the domain, we can only think about things that we are allowed to plug in, nothing that we can't break any math rules. So we can't divide by 0, and we can't take the even root of a negative number. We could take the cube root of a negative number. The cube root of -1 is -1 because -1 times -1 times -1 is -1.